Welcome to Lecture 5. Lecture 5 is based on Chapter 5 of your textbook. In your study guide, as you can see, it shows up in the third part of Module 2 or Module 2-3. What this chapter deals with and what we'll cover in this lecture, because we are providing an outline of the contents of this chapter, is the idea of variables and concepts. We have spoken about this briefly before as to what concepts are and what variables are. But the best way to understand what concepts are a collection of ideas. It's like a basket of different ideas. And examples of concepts, we can have different examples, but the key thing to remember about concepts are they are abstract, they're not sufficiently defined. So two people can talk about a concept and they can talk about very, very different things. And we'll talk about an example or a couple of examples in a second. Concepts are not, while they are abstract, it's not that they do not convey any information. Concepts can convey a lot of information, but because they are so broad and so overarching, it's hard to get a proper sense, or it's hard to get a proper measure and hard to compare concepts if the variables used to talk about those concepts are not the same. So let's take an example. This example, health. In this very classroom alone, or this virtual classroom, if I ask each of you to talk about what you think of health, we can think about different possibilities. Some people might say it's an absence of disease. We might have other students say, well, health is being fit and healthy. Fit and active, perhaps. Some people might say, well, being healthy is being, well, both physically and mentally. Some people might argue that this means you don't have too many diseases or chronic conditions. Right? Yet others might argue that, well, health is the number of, the absence of number of visits to the doctor or the hospital. So if you have two people talking about health, it's hard unless they agree to what they're talking about to actually know if they're talking about the same exact thing. Health is a concept. It gives us a very good idea. We know intuitively that health probably not just covers one of these things, probably covers all of these things. I apologize in advance, but my scribbles are going to be on the next image. But even through the scribbles, you can see what that's about. And what you see here is that you see a gentleman with a lot of dollars, and we're talking about a different concept, and if you've guessed it, it's wealth. What does wealth mean? Does that mean a high income? Does it mean high net worth? Which means you may not have a lot of income, but you might own a lot of stuff. What does it really mean? So it could mean both as well, and they're all representative of the concept of wealth. And as you can see, there are several representations for the concept of health itself. This is when, in Chapter 5, the chapter starts talking about variables. Variable, as the name suggests, is something that can vary. That's why the name variable, because it is variable. A variable is a type of concept. I will go so far to say that it is a subset. Okay. So if you think about a concept such as growth, if you're talking about infants and we think about growth, a variable could be height, a variable could be weight, a variable could be developmental milestones, and so on. As I said, a variable can vary or exist in different states, which is what makes it valuable. Instead of speaking in the abstract, saying my friend's health has improved, and without going into any specifics of what has changed about my friend, if I can actually say that my friend who's recovering from a physical injury is now able to run more kilometers a day, instead of 1 kilometer a day, he's able to run 5 kilometers. We are talking about a very specific variable, cardiovascular ability, and I can actually talk about something that's measurable, which is distance the person is able to run. And therefore now the concept of health has become very tangible by using a variable. So the variable can vary or exist in different states. In the example of running kilometers, the distance could have been 1.5 to 2.53 kilometers and so on. So it could have existed in different states. The other thing about a variable is because it is variable, the only way that we know that it's variable is it is observable. We can't talk about change unless it can be observed. So sometimes when we talk about change in terms of a pain scale, and when patients go to a doctor, they express the amount of discomfort they have on a pain scale. It is a perception of how they feel, and while the physician can't observe it, the patient themselves has a sense of what they feel like, and perhaps they can comment on how it felt to not have that discomfort in comparison to all the other discomfort they've experienced, and then they can put themselves on a scale. So it has to be observable either to the external observer or even internally, but basically the variable must be observable. Not only must the variable be observable, it also needs to be measurable. So you have to be able to have some method of measuring the variable. A change in weight is measured by a weigh scale. A change in height, you can use a ruler, a tape measure, and so on. A variable for a concept must have these features, but it also must represent the broader concept as accurately as possible. We may have the option of choosing several variables to represent a concept, but often good researchers will pick the variable that provides the best measurement possible for that concept. So for example, a good measure of socioeconomic status is disposable income. A percentage disposable income. Even broader income status might be a good measure. So these might be good measures, good variables for measuring a larger concept as socioeconomic status. So you really want to find good variables that measure concepts as accurately as possible. It has to be valid for the concept. So for example, if you have, let's say, concept, morbidity, which is having, let's talk about chronic morbidity, which means having a disease that persists with you for a lifetime. If chronic morbidity is, if you want to relate a lifestyle factor to chronic morbidity, so let's say lifestyle, while there might be several factors that impact, which correlate lifestyle to chronic morbidity, some of the key variables here that are actually accurate of lifestyle is available time, exercise, income, access to care. These might be very valid variables for the concept of lifestyle. Variables are required for the operationalization and, of course, the post-operationalization initiation of the project. And we'll talk about that, what this term means in a couple of slides. Most hypotheses that we have when we start out, when we relate to concepts, especially in positivist research or quantitative research, we make the relationship starting with broad concepts, and they're called conceptual hypothesis. So this is called a conceptual hypothesis. Now, in a previous chapter, we spoke about the need to diagram our hypothesis to get a clear idea. When we create a hypothesis, initially it's in the form of a concept. An example would be nutritional status and responsive behavior. So if you're thinking about long-term care facility and we have a hypothesis that positive nutritional status correlates with reduced responsive behaviors. So if we were to write that down, in this box we would say positive nutritional status and since we say it's negatively correlated with responsive behaviors, so this kind of a diagram, whether it's positively correlated or negatively correlated, this is called a conceptual hypothesis. As we start to want to experiment on this, this has to be more operationalized. So we need to unpack. What we need to do is we need to unpack this concept, and we need to unpack this concept as well. What do we mean by responsive behaviors? Those of you who have worked in long-term care or who have taken several gerontology courses know the definition of what that is. But if we just say responsive behavior and unless we have a list of what that means or a few sets of defined behaviors that we're looking for, anything could fall into that category and it becomes too broad. It becomes, it's a concept. Again, second example would be, using sense of purpose and mental health. Again, very, very broad concepts. In order to operationalize these, we're going to have to say, if we have to operationalize positive nutritional status, we can say number of times a week, nutritionally appropriate breakfast was consumed. So what we did here, going from nutritional status, we are actually able to measure the number of times a week the resident ate all their food that was provided, which obviously in a long-term care facility is by a nutritionist or a dietitian, so it's nutritionally appropriate. The concern obviously is that they may not be consuming all of their food because of where they are with their mental health status. Responsive behaviors can also be defined. We can have a list of different behaviors. We can choose to measure screaming, physical violence, non-compliance, and so on. So hypothesis needs to be operationalized. What happens if you don't have a hypothesis? What happens if you have a research objective because you don't know enough to suggest a relationship between two concepts? Well, you have to operationalize research objectives as well. You have to, at the very least, say, for example, if you want to talk to community-dwelling older adults who often use food banks, and you want to talk to them about how they feel about using food banks, you still have to operationalize the question very specifically as to ask them about their use of food banks and in the context of where they live, and perhaps have questions which deal with income support and their pensions, their living status, etc. This is a different example, and you have research. So another example when we are trying to operationalize research objectives is if we want to look at disruptive behavior in a classroom, if the objective is to study disruptive behavior in a classroom, we still have to kind of identify what all behaviors can be construed as disruptive behavior. Now, if you aren't a school teacher in an elementary school or kindergarten, you probably may be able to predict one or two behaviors that you consider disruptive. So let's pretend that we don't know. In that case, we would go in with a research objective to talk up to study disruptive behavior in the classroom, and then we would define disruptive behavior. So we'd operationalize disruptive behavior to say behavior that results in the teacher having to redirect a student to attention. And even though in this situation we haven't defined what disruptive behavior is specifically, we have operationalized what disruptive behavior is sufficiently enough so that the research can proceed, and obviously the behaviors themselves will start getting noticed, observed, and noted and identified as the research progresses. The next idea that your Chapter 5 talks about is the validity of a variable. Variables have to be valid for the concept. Okay. The reason they have to be valid for a concept is because there's no point in having a variable that is observable, that's measurable, which is fantastic, which is what a variable needs to be, but it's completely not valid. Let's look at a few examples of what's not valid. Are exam results a measure of intelligence? And if most of you or all of you say, no, that's not true, I'd ask you why. And you might have several reasons to tell me that. Well, the student may not be interested in the course. The student may not have purchased the textbook, no textbook. Because the student didn't want to spend the money. The student might have not had time to prepare for the exam because they were perhaps ill or busy or otherwise occupied. The professor could have mismarked an exam, right? So when you think about it, exam results, while when you get a positive exam result, that's great. If you get a negative exam result, it is depressing. They're not necessarily a measure of intelligence unless consistently, you know, even in situations when students consistently underperform on exams, it's not necessarily a measure of intelligence for several reasons, and reasons beyond these different options that I've provided. Some students are just not good exam takers, right? So exam results are not a valid variable for a concept intelligence, okay? Body weight as a measure of fitness. Unfortunately, this is a very obvious out there example which tells you that so if someone's skinny, they're obviously not necessarily fit, and if someone's a little bit overweight or bordering obese, they may not necessarily be unfit because they might be very active. Whenever we think about variables for concepts, we really have to ask the question: is this a valid measure of what we're trying to talk about? Age as a measure of wisdom. Is every old person wise? Okay, well, I can predict that most of you will agree that that's not necessarily the case. Gender as a determinant of for mathematical ability. And this is very often seen where there's an assumption made that if a child is female, they're likely to struggle with math and mathematical concepts. This is completely socially constructed. It is not true. And I have taught mathematics for several years, and I will tell you that my best students were, there was no gender connectivity to them. I had many bright female math students as well as male math students. So these are all examples of variables that people end up often using that don't measure a concept accurately. We're talking about body weight. People often use BMI, which is the body mass index, which is a distribution of body weight by the surface area of the body, as a measure of wellness. Bodybuilders and fitness athletes often have high BMI. They're extremely fit, but if you just looked at their BMI, you would think that they needed to reduce their body mass in order to be fit. So the point is, we have to consider very deeply when we pick a variable to represent a concept, whether it's valid. There's a box in gray in the chapter talking about the different types of validity. A variable has to be valid in many ways. There has to be external validity. External validity is the idea that the variable score, so for example, if you're saying a child has grown, okay, and by growth you mean the child has increased in height, and if height, so let's write this down, growth is the concept, and you're talking about variable is height. There's external validity to it. So when height changes, when height varies, and you observe a child and you can notice the height has changed, when you measure the child, the height has changed. It is externally validated. What you measure and what you see are representing the same thing. A variable has to be internally valid, which means there are no errors in the research process. So basically, when you repeat the measurement of height using a scale or a ruler or a tape, each time you do it, it's pretty consistent. Construct validity. So the construct validity is often, particularly when you use a variable in qualitative research. So oftentimes we assume that a variable represents a concept. So for example, let's say we are talking to individuals who have different forms of anxiety. And let's say let's put the concept as anxiety. And let's make the variable as restlessness or fidgety. Okay. So the construct, if we believe that restlessness or being fidgety is representative of anxiety, the variable has construct validity if we talk to the people that we're talking about that anxiety and we ask them, hey, when we interviewed you, we noticed that certain things make you more fidgety, make you more restless. We believe that those correlate to your anxiety. Do you think that's correct? And so, if you get feedback that it is truly the case, then your variable has construct validity. Content validity is a little more complex. As we mentioned before, concepts are baskets of ideas. So they have a bunch of different variables. Now, the measurement of one variable, even the best variable, is not going to capture all of the concepts. Okay, it's going to represent the concept. It's a subset. It's not going to capture everything. But is it sufficient to capture all the states? So let's pick an example here. So if we are measuring, let's say, sexist attitudes, and if we use a measure, and we'll talk about measures of sexism later in attitudinal scales and measurement instruments. But let's say you have a scale, you have a question saying, on your questionnaire, women are usually not good at math. Okay? And the choice of responses are strongly disagree, neutral, agree, and strongly agree. Okay? As you can probably imagine, people who consistently answer strongly agree to these types of questions will score highly on a sexism scale and therefore be considered sexist. But the point here is different. Now, the measure of sexism that this particular variable is using, it's capturing all states from strongly disagree to strongly agree, which means someone who's totally not a sexist or has a bias could score anywhere here, and someone who is a sexist is likely to score more on this side. Okay? So it captures the whole range of the response. So one of the things that a variable has to be able to do is you have to be able to measure the absolute low point as well as the high point of anything that you're measuring. A thermometer that goes all the way from that measures temperature in degrees Celsius goes all the way from -40 to +40 is a very good variable for heat measurement for outside environmental temperature. Okay. Yes, it may not be valid to measure temperatures, say, in a cryogenic laboratory, but for the city of Greater Sudbury, a scale of that sort, and using degrees Celsius from -40 to +40, it captures the entire range. It captures all states. So after having spoken about validity, we have to speak about reliability as well. They are two different terms. Validity does not equal reliability. This does not equal validity. Oops. Reliability is the idea that you can get the same measurement every time. Think about an electronic scale that you step on. If you step on it the first time, it tells you that you're 65 kilos. The next time you step on it, 5 seconds apart, it tells you you're 54.5. You do it a third time, it tells you you're 55.5. So every time you stand on it, it gives you a slightly different measurement of your weight. Not totally off, but different enough that you don't know which number to trust. So such a device would not be considered reliable. It's not consistent. A variable for a concept must be reliable. For example, if I gave a measuring tape to you and asked you to measure the height of a small shrub, and if I had precisely asked you to position the tape a certain way and to the top of the shrub, whether you do it or 10 other people do it, you will reach the exact same conclusion about the height of a shrub, which tells you essentially that the concept growth of the shrub or growth is accurately represented by height in centimeters or inches, whatever is the case. Weights too can be a very reliable measure if you're willing to accept a little bit of change within a plus or minus a certain number of grams. Obviously, reliability is not the same as validity. Validity deals with the accuracy of a variable in representing a concept. Reliability does not comment about whether a measure or a variable is accurate to a concept. It just says that if you use this variable for this concept, you will consistently get this answer. So a variable must have both. It needs to have reliability. It also needs to have validity. It has to have a bunch of other things I've already discussed before. A variable has to vary. It has to be in one of many states. It must be observable. And it must be measurable. So really, when you think about it, a variable has to have a lot of different things to be considered a legitimate measure for a concept. Then we go on to dependent and independent variables. I know we touched upon this in a previous lecture, but really the best way to understand this is when we diagram hypothesis, we put the independent variable on the left and the dependent variable on the right. Remember that when we relate to concepts, It does not always have to be that when the independent increases, the dependent increases. It can be when the independent increases, the dependent decreases as well. But we really want to be able to talk about the association of the two variables. When there's a change in the independent, there's a change in the dependent variable, whether it's positive or negative. That's somewhat less important here. It's good to step away from talking about whether the independent variable change causes a change in the dependent variable, because cause and effect are hard to prove with the exception of the experiment. An experimental procedure where you control for a lot of different variables allows you to actually show or demonstrate causality. Most research only can show an association, positive or negative association or correlation between variables. So what correlates, what is positively associated or negatively associated? And what variable is not dependent on what? Because not all, just because you have two variables and you hypothesize that they're associated prior to data collection, does not necessarily mean that that is indeed the case. You could have two variables that are completely not associated. Let's look at two variables that may not be associated at all with each other. Exam marks and intelligence. So you might not be able to put a plus or a minus sign here, and that's fine. Control variables are, this is in the context of an experiment. A control variable is when you control for other things that could change and confound your results. Oftentimes, they're also known as confounding variables because they could make the result quite confusing. There's a very interesting video in this module that talks about confounding results. I don't remember if it's a video or if it's a reflective activity that you have to do, but take a look at the module, and it brings you to the idea that it's how one thing, even though there's some kind of an association, there are so many confounding variables that they're not actually related. I believe the example says people without a passport are more likely to be diagnosed with diabetes. And while this sounds absolutely absurd, because there's so many confounding factors you can think about, the most obvious one being the socioeconomic status for people who apply for passports because they can travel internationally, correlates to the fact that these wealthier people also have better access to better nutrition and health care, and therefore are less likely to be diagnosed diabetic. Anyway, the point is, go through the example. Control or confounding variables are all of these different factors that skew or create the semblance of a relationship between two variables when there's actually none, as in this case. Having a passport and being diabetic, there are many things that are associated with the development of diabetes, and having a passport has got nothing to do with them. And you can think of other situations too. For example, we spoke about exam marks and intelligence. The reason you can't control, the only way you can demonstrate that an exam mark is demonstration of intelligence is if you had people with identical intelligence test scores, in identical mental health situations be given the same amount of study, same amount of study material, same amount of coaching, and then you had a control pool of people who also very comparable in intellect, did not or lower level of intellect on intelligence scores testing, if they were also provided the same opportunity, and you got to compare the two groups, and you saw that one group was decidedly better, then you could make, in that very controlled situation, you could make the argument that the exam mark is related to the amount of intelligence. But these are very tough experiments, and in laboratories, when people do experiments and they have a control group versus a test group, several variables are controlled for quite strictly. Okay, so that they don't affect the outcome of what the researcher is trying to study. Well, that pretty much brings us to the end of this lecture. Go ahead, read the chapter, answer the questions in the back, and hopefully you are maintaining your study notebook or journal where you note down your notes and what you pick up from your study modules and so on, and this will help keep you regular and ready for your assignments, and all of them will be quite easy for you to do. So that's it for Lecture 5. We will see you in Lecture 6, where we talk about variables measurements. All right, bye-bye.